heavy wooden cart dragging across dry ground, making a harsh grinding sound. This is where motion began. Over 5,000 years ago in Mesopotamia, humans created the first wheels. They were simple, solid, heavy, cut from tree trunks, thick and unforgiving. No suspension, no shock absorption. Every bump in the road felt like a direct hit to the body. Travel wasn't just slow, it was painful. To solve the challenges of early wheels, ancient engineers devised a clever solution. They began by wrapping wheels in various materials, starting with durable leather. Later, more robust materials like bronze were used to enhance the wheel's resilience. Eventually, they progressed to using iron bands, a significant leap in wheel technology. These metal rings were heated until they glowed red hot, making them pliable. Then, with precision, the hot band was carefully placed around the wooden wheel. As the metal cooled, it contracted, shrinking tightly and gripping the wood securely. This ingenious method marked the very first version of what we now recognize as a tire. However, despite making wheels stronger, this innovation came with a harsh truth. Imagine the experience of riding on pure metal, especially over rough, rocky terrain. Every movement, every bump sent a jarring shockwave through the entire vehicle. The rubber problem. Fast forward thousands of years. Rubber is discovered in South America. It seems magical at first, flexible, waterproof, elastic. But it had a fatal flaw. In heat, it turned sticky. In cold, it became brittle and cracked, completely unreliable. Then came a man who refused to give up, Charles Goodyear. He experimented for years, obsessively, mixing rubber with chemicals, heating it, cooling it, failing again and again, until one accidental moment in 1839 changed everything. Rubber mixed with sulfur, touched heat, and transformed into something entirely new. Not too soft, not too hard, stable, durable. This process, vulcanization, didn't just improve rubber. It made modern tires possible. Air changes everything. Now imagine replacing solid material with air. Sounds simple, but in 1845, it was revolutionary. Robert William Thomson created the first pneumatic tire, a hollow rubber tube filled with air wrapped around a wheel. What did that change? Everything. Air absorbs shock. Instead of feeling every stone on the road, the tire compresses and softens the impact. It was the first real step toward comfort. But again, too early, too expensive. The world ignored it. The bicycle revolution. Decades later, a simple problem changed history. A child couldn't ride comfortably. His father, John Boyd Dunlop, decided to fix it. In 1888, he created a practical air-filled tire using rubber tubing, air pressure, and fabric reinforcement. The result? A smooth, almost floating ride. People were shocked. Bicycles became faster, and racing exploded. Cities began to change. For the first time, travel felt effortless. Inside a tire, what you never see. Now let's go deeper. A modern tire isn't just rubber. It's a complex structure made of layers. The tread is the outer surface that grips the road. The sidewall consists of flexible edges that absorb impact. Steel belts provide strength and stability. The inner liner keeps air from leaking. Each part has a crucial role. Every millimeter is engineered for performance. Even the tread pattern matters significantly. Deep grooves are designed for rain and water evacuation. Smooth surfaces are optimized for racing and speed. Aggressive patterns provide superior off-road grip. A tire is not just round, it's meticulously designed. The age of cars. when cars appeared in the early 1900s. Tires had to evolve again. Speed introduced new problems: heat buildup, blowouts, rapid wear. Innovators like Edouard Michelin and André Michelin created removable tires. Suddenly, fixing a flat didn't mean replacing the entire wheel. Mass production began, cars became practical, and the world started moving faster. The radial revolution. For years, tires were built in layers that crossed each other, strong but inefficient. Then in 1946, Michelin introduced the radial tire. Its internal cords ran straight across, changing everything. Better grip, less friction, longer lifespan. Improved fuel efficiency. At first, manufacturers resisted, but eventually, radial tires took over the world. Silent innovations. From the outside, tires looked the same, but inside they kept evolving. Companies like Goodyear Tire and Bridgestone developed tubeless tires, no inner tube needed. Run flat tires, drive even after a puncture. High-performance compounds, better grip at high speeds. Even Formula One tires are engineered to last only a few laps. Because performance matters more than durability. Now we are entering a new era. Tires are becoming intelligent. Engineers are working on airless tires that never puncture. They're developing self-healing rubber and sensors that monitor road conditions in real time. Imagine this: your tire detects ice before you even see it. It adjusts grip automatically, preventing potential accidents. That future is already being tested by companies like Michelin. From a carved piece of wood to a multi-layered intelligent machine, the tire has quietly shaped human progress. Every road trip, every journey, every step forward depends on it. And yet most people never think about it until it fails.